All right, maybe we can start now. So hello everyone. Thank you so much for joining us today. Welcome to the 2023 UN Datathon training webinar on a guide to the AIS data utilization. So this training webinar is part of the 2023 UN Datathon organized by the United Nations Committee of Experts on Big Data and Data Science for Official Statistics in collaboration with the UN Major Group for Children and Youth. Well, thank you so much for registering for the UN Datathon this year. We really hope that all of you can enjoy the Datathon and develop exceptional solutions during the Datathon. So therefore, to support your journey, we here organize a series of training webinars and office hours to equip you with the skills and knowledge that you might need. Well, as we mentioned in our previous webinar, the data science this year requires participants to incorporate the geospatial element into the solution. Therefore, for this training webinar, we aim to introduce you a highly valuable geospatial related data source known as AIS Big Data, which is Automatic Identification System data. Well, today we have invited two distinguished speakers, Dr. Um, Gabriel Fuentes, the assistant professor from the Norwegian School of Economics, and Mr. Daniel Hope, the data scientist from UNCTAD, which is the United Nations Conference on Trade and Development. And today they will provide us with an introduction about what is AS data, how to use it, and share some practical use cases with us. Now I would like to introduce our first speaker, Dr. Gabriel Fuentes. He is a Master of Science in Supply Chain Engineering from the Georgia Institute of Technology, a Master of Science in Maritime Affairs from the World Maritime University, and a PhD in Business and Management Science from Norwegian School of Economics. And he is now an assistant professor at the Norwegian School of Economics. Well, apart from this, he was also the winner of the 2020 AIS Big Data Hackathon and the winner of the Idea Market competition at the Sustainability Research and Innovation Congress 2023. Now, I would like to hand over the floor to Dr. Gabriel Fuentes. So, over to you, Gabriel.
Thank you very much, Yaya. Just a small correction. We were not winners in 2020. We were runner-ups, even though we feel ourselves winners at the same time. It was a very rewarding experience to be at the Datathon on that year. So for that regards, we believe ourselves as winners.
All right.
So, so yes, thank you very much for the introduction. Yes, my name is Gabriel. I'm a professor at the Norwegian School of Economics, and we commonly work a lot with the AS data on different applications. So today is pretty much about that perspective. So I'm going to share my screen now. So could somebody confirm that you could see my slides online?
Yeah, we can see it.
Wonderful. So the today's case is going to be related to the UN Global Platform. So this is a very general and kind of top-down approach on what uses you could have on the AIS data, what type of data it is, what are the weaknesses, the strengths, how it has been used on several applications, and I will close with a very specific case on one of our latest uses of AIS within the UN Global Platform. So this is a picture of Norway. Don't get distracted with the good weather. It's not commonly like this, but it's still a beautiful place to come and visit if somebody wants to have the opportunity to come to Bergen. All right. So for today, we're going to talk about all of these aspects, as mentioned before. And the slide that I would like to start with has to do with what might be the ideal data solution in terms of applications that could be generated from different sources. So the ideal setup has something to do with having AS data, meaning real-time information of vessels going and coming from different ports in the world, together with potentially real-time port throughput from the information that came from cranes, from the schedules that they accommodate vessels from and to. Also, if we could have information on customs and authorities in real time, uh, particularly customs declarations, such that we can identify what's the volume or weight of cargo transported and the characteristics of it. And then finally, if we could have information on charter parties. Charter are the contracts between the parties on the maritime endeavor. So these charter parties has a lot of information related to uh, what is the owning company of a batch of cargo, what type of company they hire for transporting their vessels, and several implications that this type of information has. So we're talking pretty much now on the case of maritime operations, potentially trade information. Like if we got all of this information centralized at the same place, we could streamline significantly more applications given that they disclose different types of information. However, the reality is that our work so far looks something like this. So yes, we do have information on AIS for vessels, uh, automatic identification system as introduced by UI. This all goes almost on real time. Uh, there are several commercial solutions out there that charge for this type of data, and it could get very costly sometimes depending on the application you like to run. The second one, I put a big X on it because information on ports throughput is not necessarily there. I mean, in terms of being centralized and being publicly accessible. Therefore, that's some big gap we have in terms of recognizing what the ports are doing. It has its own reasoning, and it also has sense that this information is not shared, particularly regarding aspects such as business secrecy and information being valuable for several ports in the world. The customs and authorities, in many applications, and particularly on developing countries, which in many cases happens to be also large commodity trader exporters, customs come sometimes publicly, but in the form of tabulated files, such as in Excel, or probably untabulated files, such as PDF files. So it might be quite difficult to try to first clean out the data in a standardized form such that you could connect it with some other sources. And secondly, you tend to see this type of data coming months, weeks or months after the event happened. So let's say that customs in a country, let's put an example, because customs in Norway, they collected the data and they report these publicly if the law requires so, probably a month after they collected, after the event collected within the data happened. So that creates some sort of gaps in terms of applications that could be fed by real-time data. Pretty much customs declaration is not up to speed. I mean, in the world scale, right? On a standardized form. And finally, charter parties. This is very unlikely to be um, open for public access in any time soon, so to speak. The reason, once again, due to business secrecy. Brokers are the middle person between a charter, the person who hires a vessel, and a ship owner. And the broker, in many cases, is bounded by not publishing the details of the agreements between the parties. So this is information that probably will not be available in any time soon. So what's the best that we could do? Pretty much work with AIS data as much as possible, such as to proxy indicators on different application things such as trade movements, operational efficiency of ports, you name it. The sky is the limit pretty much when it comes with new applications. So the basic concept of handling AIS data starts from trying to identify, first of all, what every single individual vessel is doing, such as in the example in here. I'm just going to run this video. It's a very short one. And this is the example of a vessel transiting the Suez Canal, one single vessel. That doesn't mean that only one vessel per day transits the canal. It means pretty much that we segregated the data such that we could run an algorithm one vessel at a time. So, for instance, a vessel that comes in the Suez Canal, they had to stop at the anchorage, the place where they have to wait for transit. And from that information, you can actually compare between the first time of anchoring and the last one, what was the waiting time of the vessel, for instance. Then you will also be able to estimate the times of transit pretty much based on the difference of that vessels coming in the canal itself and the vessel finishing its transit. So, and I have to be honest, this was part of our idea for the UN 2020 Datathon, pretty much estimating these efficiency measures such as to identify uh, bottlenecks within the canal and efficiency aspects of the Suez Canal. Naturally, you may interpret that these bottlenecks, canals and the straits or passages are limited for transit. They are important for world trade and efficiency, and smooth transit could directly impact both on transport cost, freight rates of the vessels, and also having the commodities uh, uh, at the port of destination in due time. So for us, our concept with the waiting times in here was pretty much to monitor this important passage. We could not read the future, but many of you know what happened a couple of years after we developed this application. It became quite relevant in the sense of the Ever Given getting across the canal and interrupting global trade with all the implications that it had in the world economy. So digging deeper into the AIS, the type of variables that it has and what it is. First of all, AIS is a mandatory system for vessels according to an international convention, the International Conventions for the Safety of Life at Sea. So as the name of the convention suggests, AIS is primarily implemented for safety reasons, not necessarily for trade recognition or emissions recognitions or etc. However, given that this signal, the signals that goes from the vessels and to the vessels flies on either radio frequency, open radio frequencies, then the information can be collected by anyone who actually happens to have a radio receiver within some distance of the, transmitter. That says something about the flexibility that the system has for being transferred and collected. But it also says something about the limitations that the system has if it is only based on radio signal. Therefore, one of the improvements of the system that had came true and had come true with significant improvements has been the recognition of these signals by low Earth orbit satellites, which pretty much works as satellites passing through the horizon where a vessel is flying at, and the signal being transferred, and they having the capability of collecting that information also. So that also provides some sort of larger accessibility to the AIS data from the original setup, which was pretty much constrained by a very short distance, which for practical purposes from 25 nautical miles to 50 nautical miles. In translating that to kilometers, that should be almost double of it. And at the same time, no, sorry, half of it. And at the same time, it also allow researchers, people actually building applications with AIS to be capable of monitor or movement of vessels. So throughout the years and being practical as well, from 2015 onwards, we have seen a large increase of satellites, particularly being provided from private companies. And that has produced a better quality of the AIS, or so to speak, a higher frequency of AIS signals being collected as well. Naturally, with this type of solutions also come challenges, and is the fact that given that higher frequency comes on vessels, then for handling it at the other side, meaning on the researcher side, on the application side, then you need to build some additional skills to handle that, skills related to managing and accessing or manipulating big data. So big data is a large concept that, at least for my taste, doesn't have a definition because the definition keeps changing as the year pass. So I rather prefer to be very cautious on how to define what a big data is. However, we could recognize already, given the increase of data frequency within AIS, that if it's not big data per se, it is very close to be a big data set. Uh, so to speak, the way that we handle this data through the United Nations Global Platform has to do with the different cooperation that the United Nations had developed with some commercial partners, and we will get some of that in brief. So the main use, and summarizing, first of all, the mandatory use that comes from the convention is to help navigators to avoid collisions. So the picture at the right depicts the display of the system. This is not necessarily the whole system. This is the display of the system that is placed at the bridge of the vessel, such that the navigator, an officer, a navigation officer, could identify whether they have a vessel close by or not. So you use this in interconnection with the vessel's radar and the other electronic equipment, such as to avoid colliding or try to have the most information possible to avoid colliding. Naturally, the collateral use started from being a system that could be used for security surveillance. Countries have used this to identify threats to their security. Lately been used for emissions calculation. There are very robust methods to translate AIS movements and vessel type into how much emissions they emitted. Also global trade flows, identifying origin destinations or even pairs of origin ports and destination ports, including a proxy of how much cargo the vessel was carrying, and also used by fisheries and for aligning optimal routing or even weather routing schedules from them. So this is the type of data that comes in. We have two categories within the variables on AIS. One of them are dynamic variables. The other ones are static at voyage. The regulations state that for the system, if the vessel is underway, that means that if the vessel is sailing and moving, then the information is transmitted every 2 to 10 seconds, the dynamic information. So examples of dynamic information has to go with ship position. So pretty much for those working with Python, a tuple of longitude and latitude. They are float variables, meaning that they have decimals. Then you have information of speed over ground, which is actually constructed from the difference of latitude and longitude, with also the difference of the time between positions, the frequency between positions. The course over ground, which is the direction where the vessel is moving to, not necessarily where the vessel is pointing to, but the direction where the vessel is moving to. The heading, yes, is the direction the vessel is pointing to. It goes from 0 to 359 degrees and then starts at 0. If you intend to use course and heading, you have to be careful that this is a closed system. So if you use it as a continuous variable, then you may have issues when you have, for instance, 2 degrees, which is actually very close to 358 degrees, even closer than 2 degrees to 7 degrees, for instance. So you have to be careful with using course over ground and heading. Rate of turn, as this is information about how fast the vessel is turning, if they're making a large turn. And AIS navigational status, which pretty much states what the vessel is doing, from being at anchor, which is the waiting, or underway, or sailing with sails. That's another option. At berth, which means that they are alongside a terminal undergoing cargo operations, and several others. There comes the static and voyage information, which pretty much has to do with information that will not change regardless of the vessel moving or not. So the first one is the IMO number. I highlight here that the IMO number is actually the key ID. For those within the lingo of data applications and SQL, for instance, you will recognize key ID as this variable that could actually connect among data sets. So this is a very important variable for merging purposes. MMSI, which could be used interchangeably with IMO number. The MMSI stands for Maritime Mobile Safety Identification Number, and is like pretty much the phone, the mobile phone number of the vessel, so to speak. So it's like the specific number for the radio station of the vessel. Then you add call sign, the ship name, the type of vessel, a quite generic type of vessel system or category. And then you have dimensions such as length, which means the length of the vessel, and beam, which means the width of the vessel. So then you could pretty much know what type of vessel it is. The draft, which is the underwater surface of the vessel, it goes in meters, and it pretty much could be used as a proxy for whether the vessel is laden, loaded, or in ballast condition, empty. So some people use actually this variable to proxy how much cargo the vessel loaded or discharged within a port. Destination and ETA. I put an asterisk on some of these variables. I want you to recognize them because these are variables that needs to be taken with care, particularly because they are manually input by the people of the vessel. So all the other variables comes automatically from a external sensors on different systems that are within the vessel. They're connected to the system, the AIS, and they are displayed there and stored. But these that goes with an asterisk, they are introduced manually by people, which are prone to errors. So you have to be very careful when you use these data variables. And more importantly, another variable that doesn't come with AIS, but is actually collected by the reception systems, is the timestamp in UTC. I will highlight this again, timestamp in UTC. So the information of the AIS that comes attached to your database related to timestamp is actually information collected from the receivers receiving the AIS signal, and it gives the information on daytime and the UTC time of the collected information. Naturally, that gives you the opportunity to sort out your database such as to have a sequence of positions, such as the one as we saw in the Suez Canal case. So the importance of AIS is like, okay, it clutters a lot of information, but at the same time, it could be segregated in so many filters, such that you can recognize different patterns. This is an example of the Mediterranean and the type of vessels that sails back and forth. Naturally, you can see a large number of general cargo vessels and some bulk carriers passing south of Italy. What are the strengths and weaknesses? To start with, you can generate timely statistics. So try to compare this to the customs problem, which is like, okay, information is probably public, but it's not necessarily timely, such as to take decisions on that. So the AIS has the opportunity that you can build information almost in real time. At least for the UN Global Platform, you may have a 1 day lag. So you probably have information, the raw AIS data from yesterday, and you can build information up to yesterday on of any of the applications that use AIS. The aggregated data, so given that you're working with one vessel at a time and you're trying, or most of the cases work with one vessel at a time and trying to identify information for single vessels, your output database will give you the opportunity to aggregate and segregate data. So it's quite elastic in that sense. You can actually work different types of analysis pretty much based on the flexibility of the aggregation and segregation opportunities that the vessel has. And high frequency data also is important because you can recognize very microscopic in the sense of data, geospatial data, very microscopic implications in the operations based on the AIS data itself. We have a paper actually that works with identifying bunkering, fueling operations by vessels at ports. Very micro information that could be derived from AIS. Some of the weaknesses that you need to take into account, first of all, that it might not be consistent in some areas. We might have some gray areas where satellite does not cover properly. Therefore, we have missing information in some areas. Particularly close to the Singapore Strait, there's like a large gap in there where vessels information doesn't come through as frequent as in other neighboring places. The vessels themselves can switch off the equipment, therefore they become dark, so to speak. And it could be on different reasons. One of them is like probably they're in piracy areas and they don't want to be detected by pirates. And very lately, it has to do with sometimes illegal activities. For instance, transporting embargo cargoes or doing some unlawful activities. And although all other weaknesses, as we mentioned before, is that the manual input of data is based on crew proactivity, such that they actually update that information first correctly, and secondly at the real time where the vessel change of operation activity. So particularly that they were quite proactive when the vessels changed from being at anchor to when it starts at berth, and when it stops berthing to start on their way, for instance. So this is not a warranty, so to speak. Another database that comes in handy because as we mentioned, the AS data has limitations. One another limitation that it has is that it does not have all the information of the vessel specifications. So for that, the UN Global Platform has an additional database provided by a different supplier, which actually has information at the vessel level of different characteristics of it. You could name the number of tanks, the capacity of cargo, the capacity of loading cargo of the vessel, how many cranes it has, you name it. Large amount of categories. The engine, type of engine that the vessel is using, etc. So the supplier of this database is IHS Market, and the United Global Platform has an Amazon S3 bucket where this information is stored and is updated on a regular basis. So you could have up-to-date information on the vessel characteristics, even things such as if the vessels change their IMO number, for instance. Naturally, as I mentioned and highlighted before, the connection to this database has to do with the IMO number. The IMO number is on both databases, therefore you could be able to match them. If you're missing the IMO number on one of the databases, you can also try the MMSI number, which also happens to be a unique number. So these are key elements for handling and connecting these two databases. So handling AIS is pretty much driven on the same concept of any big data application, which is like perform simple operations on a large sample with the cluster as much as possible. And if you need to write your results afterwards, aim to reduce as much as possible and aim to filter as much as possible such that you can have an end product which is actually writable. Uh, Plus, an important part of this is that as an agreement with the supplier, raw data cannot be exported from the UN Global Platform. And the system has gotten better and better to avoid users exporting the raw AIS data. So if you want to make good use of your time, just disregard that option because it's going to be painful for you probably because you're going to spend some time doing something that probably you will not be able to do given the size of the data, and then you will lose some time in building your own application. So try to build everything within the cluster of AI, UN Global Platform and reduce it as much as possible such that when you export, you can export actually a reasonable size file with the final results. This is actually agreeable with the supplier as well. You can actually export derived results from the AIS, not the raw AIS data. The UN Global Platform, and very briefly because I'm running out of time. So you're going to be the users of a Jupyter notebook, which is connected to a Jupyter hub. This was the latest. This is an old drawing. This was data mechanics before. We're working with Spot now. But pretty much everything, all the resources from the clusters are behind a connection to the Spot environment. But you have to only worry about working with the data in your Jupyter notebook, the one that you're going to be provided by the UNGP. In there, you will have information of the AS data, the raw one, the vessel specification, but also some inbuilt functions accessible from GitLab repository that the AIS group has constructed throughout the years. So this actually helps you in filtering, making more efficient filterings of the data and even accessing the data faster. So try to ask for the inbuilt functions for AIS from the GitLab repository from the AIS group. So talking about applications very briefly, one of them you could perform very easily with AIS is identifying port visits, which is interpreting origin destination ports. You do so by taking two steps. The first one, constructing geofences or polygons. So polygons are a closed set of points that starts and ends at the same point, such that you could recognize when a vessel's AIS position comes in and out of that point, and you can actually build it such as to recognize ports or related. So we have a group that actually developed a model for constructing these polygons in based on AIS itself, and that I will share for I will have it available for the Datathon as well, which I should share for the next couple of days. So pretty much that's going to be a database of polygons of ports, such that those of interest could use it for their applications. And there are more detailed algorithms of this. Congestion measurement, which could be an indicative of two elements: low service at ports, large demand at the port, and or both. So the ways of estimating congestion is pretty much by filtering once again the vessel that gets inside a polygon, get rid of all the rest, and then make a count of unique vessel IDs via IMO number, which is the unique key ID in there. And some other application that comes to mind, and this is based on the literature on AIS and export prediction, detecting dark vessels, emissions estimations, etc. I'm going to close with the case of the Panama Canal, which is a project that we're working together with the UNGP, and it's pretty much identifying emissions from vessels surrounding the Panama Canal together with the waiting times at the Panama Canal. So two databases that are constructed from the same code, pretty much identifying the waiting times, but at the same time identifying the emissions of the vessels. And that's based on a model which framework is included in the fourth International Maritime Organization Greenhouse Gas Report. So this information goes in there. It's very detailed and it's very long. It's about 500 pages, but we are delivering soon with the UN GP a, a an e-learning course that teaches you actually how to estimate emissions regardless of where your port is based on the UNGP AIS data. So more information on that would come after the Datathon, I assume. I will also supply information for the UN Datathon. So you will have a database, not necessarily clean, but constructed of waiting times per vessel at the Panama Canal. This has been relevant for the last couple of months, particularly on long queues in the Panama Canal produced by draft in the lake levels. And I will also include emissions information of the Panama Canal, pretty much constructed from the information that fits this dashboard that you can actually follow pressing on this, going to this website. Other than that, that's it for my presentation today. I appreciate very much your attention, and I'm very keen to hear your questions, and I will be happy to answer them. You're muted, Yayo.
All right. Thank you, Gabriel. Thank you so much for sharing the knowledge with us. I'm sure that is very useful for our data science participants. And we will have a short Q&A session by the end of this webinar. So dear audience, if there are any question you want to ask to Gabriel, you can put it in the chat first. And next, I would like to welcome our second speaker, Mr. Daniel Hopp. Well, Daniel, thank you so much for joining us today. Let me introduce a bit about Mr. Daniel Hopp. He is a data scientist with the UN Global Crisis Response Group. Before joining the United Nations in 2020, he worked in private sector as an analyst at a private equity fund, as the head of analytics at an e-commerce startup, and as the principal data scientist for an IoT startup. At the UN, he is trying to leverage his experience in data ecosystem, machine learning and programming to drive innovation in the domains of trade statistics, economic forecasting, and official statistics. And he was also the mentor and jury member for last year's UN Big Data Hackathon. Now I would like to hand over the floor to Mr. Daniel Hopp. So over to you, Daniel.
Thank you, Jaya. So let me share my screen quickly. You can see it all right?
Yeah, I can see it.
Great. So thanks very much, Gabriel, for that introduction to AIS. What I'm going to present here is a more focused and concrete case study so that the participants can get a better idea of how to take this very, in some ways, very powerful but very daunting AIS data set and how to make it more usable and what a real world use case can look like. So the case study that I'll be talking through is looking at changes in maritime traffic in the Black Sea. So we'll talk a bit about the context, what was the baseline that we're working from, what the problem was, how AIS helped us to solve it, and then conclusions and further learnings we have from the exercise. So quickly, the background of the situation in Ukraine and the Black Sea was that prior to the 2022 war, Ukraine was a top exporter of a lot of different agricultural products. For instance, the 5th largest exporter of wheat in the world and 3rd largest corn exporter in 2021. But they also produce a lot of other agricultural products, like a lot of sunflower oil, for instance, and in general, a large agricultural producer. And prior to 2022, the vast majority of these were exported via bulker ships out of Ukraine's Black Sea ports. And those ports were cut off following February 2022 and the invasion due to naval action, blockades, mining, mines, etc. So pretty much from one day to the next, those huge outflows of Ukrainian exports were cut off. And the fear in the aftermath of that conflict was that as such a large supplier of foodstuffs and grain, that would have ripple effects on the global food security and food prices. And this is a chart of the FAO Food Price Index, basically showing that those fears were borne out in the immediate aftermath of the war. So from 2016 to 2020, food prices were more or less stable, some small variation. But starting around COVID, prices were rising quite strongly. And then at the black line here, after the war, you can see that the prices spiked even higher afterwards. So there was a clear issue with the global food markets and food supply. So in an effort to combat those effects, the UN brokered Black Sea Grain Initiative, later changed the name to Black Sea Initiative, with the help of Turkey, was agreed upon to allow the reopening of exports of foodstuffs, grains, etc., out of Ukrainian ports. Prior to the deal, in the months between, let's say, February 2022 and August 2022, when the deal was put into effect, the only way for Ukraine to get its grains to market and exported were either via road and rail over land or via the Danube River ports. All of these outlets have a much smaller capacity than the sea ports had. So that was a big crimp on Ukraine's ability to get its grains out. So that's the background, that's the context we were working in. And so what's the problem with monitoring that situation? So following the signing of the initiative and observing that the conflict had these detrimental impacts on global food markets, there was a need for a way to monitor what was actually the result of the deal, what was going out. The traditional approach, so using more classical data, would have been to look at Ukraine's trade data. For instance, from Comtrade, UN Comtrade is a trade database where countries report their exports and imports, customs, etc. And that would have been, in the past, probably the go-to way to monitor the impacts on the trade that Ukraine was actually able to do. The problem with that, which Gabriel touched on before, talking about the customs information, is that this information is very frequently, if not always, supplied with a very long time lag. So in the instance of Comtrade, the lag of reported trade data can be anywhere from 3 months up to a year, depending on the reporting country. And on top of that, on top of these normal publication delay issues, there is the matter of Ukraine being able to produce statistical data during wartime. So we could anticipate probably even bigger delays in publication than we historically were used to. So all of that together meant that trade data would be more or less useless for the timescales that we were interested in terms of monitoring the progress of the deal, where we had to look at data or look at the situation on a daily or weekly basis. The traditional approach would have enabled us to only look at it on a, let's say, 3 months from now, 4 months from now, when the length of the deal sometimes didn't even go past that. So it was very difficult to actually have an idea of the deal's impact in regards to how the traffic was before, without a resource like the AIS data, which is extremely timely. And on top of that, Ukraine's reported trade data is all lumped together, so you can't disaggregate it by by port of departure, by method of transport. Is it coming out via the river? Is it coming out via road or sea? Some countries do report that now in Comtrade. In Comtrade Plus, they have method of transport, but it's still many countries, including Ukraine, don't report that information. So it's really a black box in terms of where the exports are actually coming from. So if we observe increases in the trade data, we can't be sure if that's coming from the Black Sea seaports and the ships under the deal, or if that's coming through expanded capacity of the Danube River ports or increased rail capacity. So that was the problem facing us. And now I'll talk about how AIS essentially addressed all of these problems and gave us insights into the impacts of the deal. So these are basically the key characteristics of AIS data which enabled it to be useful in this case. And these are the characteristics to keep in mind if you have a use case for AIS data. This is basically the advantages that they provide. Number one, as Gabriel mentioned, they're more or less real time. The raw data themselves are real time, but as Gabriel mentioned, on the global platform, you'll have a lag of about 1 day. So for today, we can get the maritime traffic of yesterday, which if you're used to the normal publication delays in the world of official statistics, this is basically no lag. On top of that, the data are disaggregated. So all the data is available for an individual ship at an individual moment in time. So when you have complete disaggregation, that means that you can aggregate to whatever level it is you desire. So in our case, the desired level of aggregation was traffic at individual ports on the aggregate level, let's say on a daily or a weekly basis. And because the data is so disaggregated down to the individual vessel level, that was no problem. Whereas if we look at the trade data, which is aggregated at a much higher level to the country level, it would be pretty useless for being able to say that this port is functioning well, that port is not functioning, etc. And then finally, the aspect of AIS that's one of the most useful is its global coverage. So AIS data is available for pretty much any ship anywhere in the world. As Gabriel said, sometimes they can turn off the transmitters for legitimate or for nefarious reasons, but the vast majority of the time, the transmitters are on and functioning properly. So you can get data for anywhere in the world, independent of local conflicts, local governments wanting to not publish the data or publish it later, etc. You'll always be able to access the AIS data for the waters around that country. And so these three things together meant that even in a war situation that Ukraine was under during this time, we could still get data about it out. So as you probably saw from Gabriel's presentation, there's a lot of information in the AIS data. There's a lot of fields, a lot of caveats that you have to be aware of. It's very raw data. It's not presented to you on a silver platter for you to take your insights and your action out of it. It takes a lot of work to massage it and transform it into something actionable. So what we did to get something useful out of that data is determine the coordinates of the 3 Ukrainian ports that were included in the initiative, along with the coordinates for the Bosphorus Strait. So if you're not familiar with the geography of the Black Sea, all the traffic from the Black Sea has to pass through the Bosphorus Strait if it wants to reach the broader oceans, Suez Canal, Atlantic Ocean, etc. So all traffic that's not intra-Black Sea trade has to come through the Bosphorus Strait. So then, to having identified these 4 key geographies, we calculated the number of unique ships that came within a kilometer of those ports and the strait on a given day. And then using those figures, we could get real-time insights into what the impact of the initiative was in the end on maritime traffic and trade. And we could even disaggregate it by vessel type to see what types of vessels were impacted by the deal. So this plot shows the results of that analysis, and on the y-axis you see the number of unique ships passing through. This is the Bosphorus, This is a rolling average just to smooth out, on a given day, a weekend, etc. You can have very jumpy figures. So this is a 30-day trailing average, but it shows the number of unique ships traveling through the Bosphorus over time. So you can see that before the war, so this first dotted line is February 2022, we averaged around 60, 63 ships per day passing through the strait, cargo ships, and about 18, 19 tankers per day. And of course, after the outbreak of the war, you see a precipitous decline, falling from about 70 ships per day all the way down to less than 50 per day. And obviously, there's a lot of traffic that happens on the Black Sea that's not Ukraine. There's a lot of Russian ports, Turkish ports, etc. But clearly, there was an impact from the war. The number of tankers decreased as well, but not as much. This makes sense because the Ukrainian shipments are largely cargo ships. They don't export a lot via tankers. So the traffic of tankers was affected much less, if kind of at all. You can see that in the period between the outbreak of the war and the signing of the first initiative, that the number of ships stayed lower than it had been before, averaging around 55 ships after it had been 65 ships before. And then you can see very quickly the impact of the initiative. Once it was signed, the number of ships rose again almost to pre-war levels before declining again in the run-up to the renewal of the initiative. You can see these patterns a bit more clearly if we take a look at Odessa, which is one of the bigger ports covered under the Black Sea Initiative. And you can see that prior to the war, there was about 6 to 7 cargo ships traveling to Odessa on a daily basis, and about a tanker every other day or so as well. Here you can see that the difference is much starker because these ports were completely, essentially blockaded and not functional in the period between February 2022 and the signing of the initiative in end of July. So you can see that the number of ships drops to 0. So this is 3. That's likely because there were just 3 cargo ships anchored in the port that couldn't leave, and they just continually were there. You can see there's no variation. There's no ships coming in, going out. It's just basically a dead port. Similar story for tankers. And then immediately after the signing of the deal, we saw a recovery of the number of ships, cargo ships entering and exiting Odessa to more or less pre-war levels. But again, a decline in the run-up to the renewal of the deal. So if you're familiar with the timelines of how that happened, the renewal of the deal was not a given, and it was not known until very late, very close to the deadline, that it would be renewed. So you're seeing some responses to that uncertainty before the actual deadline. And then again, you saw recovery after the renewal, but not to levels even of the previous renewal as the overall situation became more and more unclear. So what did this actually help us do? How was this helpful for us? So first of all, it was helpful to quantify the impact of the initiative, as well as identify how far below Ukrainian port traffic remained even after the signing of the deal. So some of the data on ship voyages was available from the Black Sea Initiative itself because they were reporting on the ships that were coming out. But we did not have, for instance, a relative measure or a ground truth of how many ships it was before the outbreak of the war, which is exactly what the AIS data gave us. It showed us what the levels of maritime traffic in Ukraine were before the war to give us a relative measure to quantify the continued shortfall of Ukraine's exporting capacity, etc. It also helped us identify a key aspect of people's behavior around the deal, and that is namely that the vessel voyages began to drop before the deal actually expired. And the reason for that was that given the amount of time that it took to schedule, charter, and get these ships out under the conditions of the deal, because there were increased waiting times and inspections, etc., the operators basically responded to uncertainty around the deal as if it wasn't going to be renewed, and so they would not charter ships to take those voyages because they were not sure that it would get out in time before and if the deal expired. So this really drove home the importance of basically transparency and communicating the progress of the talks to markets, because the uncertainty of whether or not the deadlines would be renewed essentially acted as a de facto deadline, as shippers and commercial operators treated it as if it would not be renewed, so they didn't want to take the risk of getting ships stuck or not being able to get insurance, etc. So what basically were the learnings from this? What can you take away from this in your own applications? The main takeaways are these four key characteristics of AIS offering very timely data, completely disaggregated data, and universal coverage of data. So if we think in this context of the Black Sea maritime traffic, what else could we do with this? This is a rather blunt measure of the maritime traffic. You can get a lot more complex with it, but it surely served its purpose of giving us a quick real-time insight to what was happening on the sea. We could extend it further by finding out insights to how Russian trade patterns developed in the aftermath since 2022. So Russia stopped reporting trade data in February 2022. So basically, you're limited to mirror data and other kind of indirect measures of Russian trade. AIS data can be a very good proxy for getting information on that. It could also be worked and analyzed in more detail to, as Gabriel mentioned, get information on waiting times. So a very valuable one would be to understand how much longer those ships had to wait to export under the BSI than they did in the pre-war time. So that can give a good indication of the premium that shippers are having to pay in terms of longer waiting times and longer shipping times to export under that deal. And finally, it could also help us to quantify and map out shifting trade patterns since 2022. There's a lot of speculation and by now trade information coming out showing how Russian exports have started to be rerouted to other parts of the world away from Western Europe and other parts of Europe due to sanctions, etc. So AIS data can show you that in real time how ships leaving Russian ports have changed their voyage behavior. So hopefully this case study has shown how you can start with this very big and intimidating data set with all this infinite information and really distill it down to something useful on a really applied level. So all those properties I talked about, the coverage, the flexibility, timeliness, make it a unique asset for analyzing trade, maritime traffic, emissions, etc. But it's just up to us and the people listening to this webinar to really unlock it and find the applications and get the value out of it. So that's why it's really important what the UNGP is doing to make this data available to a broader audience. So that's it for me. We can move to any questions for me or Gabriel.
All right. Thank you very much, Daniel, for your great presentation showcase for our participants. I'm sure that is very inspiring for our audience. Now, I would like to open the floor to questions. So, dear audience, if you have any questions, please let us know in the chat so that we could activate your microphone or read your question. All right. So maybe I have a question for um, Daniel, because Mr. Daniel Hopp is one of the experts in our UNAS task team and also the mentor of last year's UN Big Data Hackathon. So that Daniel, you must have read a lot of use cases of utilizing AIS big data to support the sustainable development. Therefore, could you please briefly give us some more examples of use cases that you think that might be inspiring for our audience?
I think Gabriel actually has a lot of more of these. So, but from my perspective, a lot of the value of AIS is in this timeliness aspect. So if you look at something like forecasting or nowcasting, what AIS can do is give timelier information on kind of many SDGs. So many SDGs are published with SDG indicators are published with lags, and the coverage may not be great. And so what AIS data can do is basically create that linkage between, let's say, trade is an easy one, but other indicators that could be related to maritime flows, create that model to tie it to AIS data, and then you have AIS data immediately, so you can get advanced information on the SDG indicators using that information. But I think that Gabriel will have more inspiring ones. I'm very much a modeling, forecasting kind of person.
Yeah, well, thank you. So I see one question that is one of our audience ask Gabriel to go back to the last two slides and give a deeper explanation.
Yes, well, I could try. So for the last two slides, I may assume has to do with the case that we made out of the AS data, which like is working with the emissions and related. Yes, of course. So this is a continuation of actually our datathon participation, which was pretty much the first thing benchmarking the emissions of vessels coming to Panama, and thereafter also benchmarking the waiting times, such as to promote the inclusion of a concept called just-in-time arrival, which is that vessels slows down their speed such as they could reduce emissions. So naturally, this goes connected to several UN SDG, particularly climate action, very, very driven towards reducing emissions from ships. And the ways that this work is that we use AIS data to transform it to emissions per vessel level, and then we aggregate and segregate depending on the analysis we want to do. The final outcome of this was a dashboard that is updated almost daily for emissions of that same area. And we're working together with the UNGP for an e-learning course, such other people could also create their emissions estimations. That's the overall aspects of these two slides.
All right. Thank you. Thank you very much. So I see one more question asked to Daniel. So that what software are you using for the analysis for your presentation?
The presentation itself, or the backing information of the
I think it's about the code thing.
AS data. I just use like a LaTeX profile for what's the word? Yeah, template for the presentations. But then the code was always done on the UNGP, like the Jupyter notebook, to get the AS data, and then R for the plotting.
Okay, thank you. I have see one more question. So, what are the AS data sources? Like it is paid or public?
So the data source itself that comes from vessels, that's public. That's collected by commercial companies, which actually sell it because they have to develop the infrastructure for collecting the data, which is launching the satellites and having all the radio stations to pick up the public and available data information. So naturally, the UNGP, what they did is like they went through an agreements with these commercial companies, which collected the data commercially and bring them out to the UNGP, to the UNG platform. And I think that's also a question related to ethical issues concerning the use of AIS data. I work in Norway. We're very serious about data protection. We have a very stringent law about it, and we follow every single step of that. Fortunately, AIS data cannot be used for deriving into individual level. So you don't know what actually the persons working on the vessels are doing, or you don't know information of the persons such as their names or their IDs or etc. You only know the vessel. The vessel as a public good, as something that is moving from back and forth, and the information is publicly collected also from the radio signal that it emits. So all in all, it's quite safe to use it in terms of ethical concerns. And yeah, I would encourage you to do so.
All right, thank you so much. So I have one more question for Gabriel. That and is that dashboard public? Can you please share the link so that they could take a look at it?
Yes, I just share it on the chat. Feel free to access it.
Oh,
Yeah.
yeah,
And
great.
that data that fits that dashboard is going to be made available for the Datathon as well. So you can work directly on the database instead of trying to export it from somewhere. So that's going to be made available for the Datathon.
All right, thank you so much. So now it's like 9 o'clock. So that all right. So before the end, there's one more thing I want to highlight. We are also organizing a series of data experts office hour every Wednesday in this October. That is experts from Amazon, AWS, and S-Ray could instruct you about how to use our platform and answer your questions. If Dear audience, if you are not familiar with what about like how to use Spark, how to use AWS Cloud, and how to use the ArcGIS, it is highly recommended to join our office hour. So today's office hour is from 9 a.m. to 10:30 a.m. New York time, and I would put the office hours link into the chat. And all right, so that's it for today's webinar. Thank you very much, Gabriel. Thank you very much, Daniel, for your great presentation.